Cryptography is the theoretical foundation of security. Before the modern era, cryptography focused on message confidentiality and referred almost exclusively to encryption. In recent decades, the field has expanded beyond confidentiality and concerns to include techniques for message integrity, digital signatures, secure computation, and so on. In this chapter, we talk about cryptography briefly. Topics include symmetric encryption, asymmetric encryption, hash function, message authentication code, digital signature, and key distribution techniques. The emphasis is on the most important and most popular algorithms. The first section is symmetric encryption. Symmetric encryption was the only type of encryption in use prior to the development of public key encryption. In the late 1970s, it remains by far the most widely used of the two types of encryption. The figure shows the model of symmetric encryption. A symmetric encryption scheme, also called a symmetric cipher, has 5 ingredients: plaintext space, the set of all possible messages; ciphertext space, the set of all possible ciphertext. A ciphertext is a transformed and incomprehensible message. Key space, the set of all possible keys. Encryption algorithm takes keys and plaintext messages as input, performs transformation on plaintext messages and outputs ciphertext, with the encryption key K as one input. The encryption algorithm transforms a plaintext message X into a ciphertext message Y. We can write this as Y equal E left bracket K, X right bracket. So Y is the function of the plaintext message X and the key K, produced using encryption algorithm. E. Decryption algorithm takes keys and ciphertext as input, and outputs original plaintext messages, with the ciphertext Y and the key K as input. The decryption algorithm D can recover the plaintext message X equal D left bracket K, Y right bracket. To use symmetric cipher in a secure manner, there are 2 requirements. The encryption algorithm needs to be strong, such that an opponent who knows the algorithm and has access to a number of ciphertexts, together with the plaintext, would be unable to decipher other ciphertexts or figure out the key. So we should make sure there is no security vulnerability in the algorithms. Sender and receiver must share the secret key in a secure fashion, and must keep the key secure. If someone can discover the key and knows the algorithm, all communication using this key is readable. In practice, the encryption and decryption algorithms usually are public known, in order to enable widespread use. Thus, the security of symmetric encryption depends on the secrecy of the key, not the secrecy of the algorithm. In other words, to protect data encrypted using a symmetric cipher, we need to keep the key safe. There are 2 general approaches to attack a symmetric encryption scheme. Brute force attack. The attacker tries every possible key on a piece of ciphertext until the original plaintext is obtained. On average, half of all possible keys must be tried to achieve success. Cryptanalysis. This type of attack relies on the nature of the algorithm and exploits the characteristics of the algorithm to attempt to deduce a specific plaintext, or to deduce the key being used. If a symmetric encryption algorithm has security vulnerabilities, it is easy to break it.